Into this lesson, we'll be looking at exponential equations leading to simultaneous equation. And if you have not subscribed to this channel, kindly be the first person to subscribe so that when a new video is being uploaded, you'd also be the first person to be notified. Now let's get started. When we talk of exponential equations, we're talking about an equation involving powers of numbers. For example, we have 3 exponent x plus 1, which is equal to 81, or 2 exponent y, which is equal to 2 exponent 2. Any equation of this form is what we call exponential equations. We have exponential equations leading to 1, the linear equations, 2, the quadratic equation, and 3, simultaneous equation. We've learned earlier on exponential equations leading to linear equation and quadratic equation, and so you can check it out. But today's video is going to focus on exponential equations leading to simultaneous equation. Having known this, then let's solve 1 or 2 examples on exponential equations leading to simultaneous equation. Now the first one says that solve the simultaneous equation 3 exponent x plus 1, which is equal to 9 exponent 4, and 5 exponent y plus 2, which is equal to 125 exponent x minus 1. And you have to write our solution. And we have our question as 3 exponent x plus 1, which is equal to 9 exponent 4. So this is the first equation. Now, in this, we first going to reduce the exponential equation to linear equation, and then we solve them simultaneously to find the value of x and y. If that happens, we know that we can resolve 9 for it to have a base of 3 and then an exponent. We know 9 to be the same as 3 exponent 2, which means you have 3 exponent 2 here. And our existing exponent as 4. When we come to the left-hand side, we maintain the same thing, x plus 1. If that's the case, then we can multiply the exponent at the right-hand side. So that is 3 exponent 8. That is when 4 multiplies 2. And then we maintain 3 exponent s plus 1. At this moment, we can see that the bases are the same, and therefore we can equate the exponents, which means x plus 1 is equal to 8. In making the value of x, or find the value of x, then we have s to be equal to 8 minus 1, and s is equal to 7. Now this becomes the value of x. Since we are dealing with 2 variables, then we can label this as equation 1. Now let's try and resolve the other equation. The other equation, we have 5 exponent y plus 2, which is equal to 125 exponent x minus 1. In resolving it, we know 125 can be expressed for it to have a base of 5 and then an exponent of 3, which means 125 is the same as 5 exponent 3. Now we have our existing exponent as x minus 1, and on the left hand side we have 5 exponent y plus 2. If that happens, we can simplify the exponent, and on the right hand side we have 5 exponent 3x minus 3. That is when 3 multiplies the exponent x minus 1. We maintain the exponent and the base at the left hand side, that is 5 exponent y plus 2. Now we can see that the bases are the same, and fast forward, we can equate the exponent, which means y plus 2 is equal to 3x minus 3. Now we've been able to find the value of x to be 7, which means this one is going to help us to find the value of y. So with that sense, we can make y the subject. That is y is equal to 3x minus 3, and 2 cross the equal sign becomes minus 2. In making y the subject, we can simplify and we have y to be equal to 3x minus 5. Now this is an equation in terms of y and x, but we know our x value to be 7. So fast forward, we do quick substitution. And if that happens, we write here by substituting equation 1 into equation 2, which means you have to label this as equation 2. Now by quick substitution, then we have our equation 2, that is y to be equal to 3x minus 5. So if x is equal to 7, then y is equal to 3 multiplied by 7 minus 5, which means our y value now is 3 times 7 minus 5. And y is equal to, now 3 times 7 is going to give us 21 minus 5. And our y value now is equal to 16. So now we can conclude that our x value now is equal to 7 and y is equal to 16. And this becomes the value of x and y. Now let's move to the next equation and next question. We also have, or it says that the values of x and y from the equations below. We want to find the value of x and y from the equations below. And the first equation, we have 3 exponent x minus 1, which is equal to 2 exponent y minus 1. And we have 1 out of 3 exponent 2x, which is equal to 1 out of 9 all exponent y plus 2. So we have our solution. And let's deal with the first equation. We are going to resolve it to linear equations and find the values of x and y by solving them simultaneously. We have 3 exponent x minus 1, which is equal to 2 exponent y minus 1. Now we know 27 can be expressed for it to have a base of 3, which means 3 exponent 3 is going to give us 27. 3 exponent 3 gives us 27. And then our existing exponent as y minus 1. And then when we come to the left hand side, we have 3 exponent x minus 1. If that happens, before we equate the bases, since they are the same, before we equate the exponents based on the fact that the bases are the same, let's first simplify the left hand side of the equation. Sorry, the right hand side, which means 3 exponent 3y minus 3. And then on the left hand side, we have 3 exponent x minus 1. So now that the bases are the same, we can equate the exponents. So we have x minus 1 to be equal to 3y minus 3. Now we can group like them, such that the variables will go to one side and then the non-variables or the constants will go to the other side. By so doing, then we have x. Now when 3y cross the equal sign, it becomes minus 3y. And we have here as minus 3 plus 1. If that continues, then we have x minus 3y, which is equal to minus 3 plus 1 gives us minus 2. And so we can label this as equation 1. Now let's work with the second equation. Now in the second equation, we have 1 out of 3 all exponent 2x, which is equal to 1 out of 9 all exponent y plus 2. And with this, in indices, we said if we have 1 out of a, then we can write it as a exponent minus 1. So in the same way, if you have 1 out of 3, then we can write it as 3 exponent minus 1. Having known that, then it means we can write this as 3 exponent minus 1 all exponent 2x, which is equal to, you can also have 9 exponent minus 1 all exponent y plus 2. Now in this case, we can express 9 as 3 exponent 2, and before that we can simplify the left hand side of the equation, and that becomes 3 exponent minus 2x, which is equal to 3 exponent minus 2 all multiplied by y plus 2. Now we continue, and when we simplify the right hand side of the equation, then we have 3 exponent minus 2y minus 4. Now with this, we can maintain the same value at the left hand side, and we have 3 exponent minus 2x. Now we can see that the bases are the same, and we can equate the exponent, which means minus 2x is equal to minus 2y minus 4. Now, in grouping like terms, then we have minus 2x plus 2y, which is equal to minus 4. Now we can reduce the coefficient of this equation and then the constant term by dividing through by 2. So we divide here by 2, divide here by 2, divide here by 2. And if that happens, we have minus x plus y, which is equal to minus 2. So we can name this as equation 2. Now with this idea, we solve them simultaneously by elimination method. There are two ways of solving simultaneous equation, either by substitution method or by the elimination method. But in this case, we are going to use the elimination method because it's the most easiest and the most simplest one to use. So if that happens, then we write equation 1. So solving by the elimination method, then we have equation 1 as x minus 3y, which is equal to minus 2, and equation 2 as minus x plus y, which is equal to minus 2. Now the method of elimination, we can either add or subtract. In this case, we are going to add the two equations. So when we add, we know x plus minus x is going to give us 0, and minus 3 plus y is going to give us minus 2y, which is equal to minus 2 minus 2 is going to give us minus 4. And so in this case, our y value here is 2y equals to minus 4. By dividing both sides by 2, minus 2, that's the coefficient of y, minus 2, and we have y to be equal to positive 2. Now in this case, we go ahead to solve the value of x. We go ahead to solve the value of x. So we're going to substitute the value of y into any of the equations. So you can substitute into equation 1 or equation 2. So in this case, we are going to choose equation 1. So from equation 1, we know that x minus 3y is equal to minus 2. And so when y is equal to 2, that means our x is minus 3 multiplied by 2 is equal to minus 2, which means x minus 3 times 2 is 6. We have minus 2 here. And therefore, our x now is equal to minus 2 plus 6, which means x now is equal to positive 4. So this becomes the value of x and y. Then we can conclude that therefore, x is equal to 4 and y here is equal to positive 2. So we move to the next question. And in example 3, it says that solve the simultaneous equation x plus 5y is equal to 3 and 2 exponents x out of y is equal to 1 out of 4. So we have our first equation, which says that x plus 5y is equal to 3. Now, since this is a linear equation already and not in exponential equations, we don't do anything to it. So what we can do here is to label it as equation 1. Now, when we come here, this is an exponential equation, so we have to reduce it to linear equation, which means 2 exponent x out of y is equal to 1 out of 4. And when we come here, 4 can be written as 4 exponents minus 1. And we maintain our 2 exponents x out of y. Now, 2 exponents x out of y is equal to 4 can be written as 2 exponent 2, all exponents minus 1. And at this end, we have 2 exponents x out of y, which is equal to 2 exponents minus 2. Now, if that happens, we can see that the bases are the same, so we can equate the exponents. And we have x out of y to be equal to minus 2. Now, we can cross multiply, and hence we have x to be equal to minus 2 multiplied by y. So this becomes the value of x. So before we can get x, you have to multiply 2 times negative 2 times of y. Now, solving this simultaneously, we can substitute x equals minus 2y into equation 1, which means you can say from equation 2 we substitute into equation 1. So having written this, then our solution continues. And so at this end, we have equation 1 as x plus 5, which is equal to 3. So which means equation 1 is x plus 5, y is equal to 3, if that's correct. Good. Now, if x now is equal to minus 2y, then means we have minus 2y plus 5, y which is equal to 3. And hence, minus 2 plus 5 gives us positive 3, y which is equal to 3. And fast forward, we can find y by dividing the coefficient of y at both sides of the equation. And now, our y value now is equal to 1. And this becomes the value of y. Now we can get the value of x from equation 2, because we said to get x, then you have to multiply negative 2 times of y. Then we can quote that from equation 2, we know equation 2 to be the same as x to be equal to negative 2y. So if y now is equal to 1, then our x value here is equal to negative 2 multiplied by 1, which means our x value now is equal to negative 2. So now we can conclude by saying that therefore x is equal to negative 2, and our y value now is equal to 1. And that becomes the value of x and y. Now to the last question we have. Solve the simultaneous equation for exponent 2x plus y, which is equal to 1 out of 256. And we have 2 exponent x multiplied by 4 exponent y, which is equal to 8. Now, in this instance, we are going to deal with them equation by equation, which means with the first one, we have here as 4 exponent 2x plus y, which is equal to 1 out of 256. Now we can resolve 256, 1 out of 256 as 256, all exponents minus 1. And we maintain that of 4 exponent 2x plus y. Now we know that 256 can be expressed for it to have a base of 4 and then an exponent, which means 256 is 4, exponent 4, that gives us 256, and our existing exponent minus 1 comes. And then on the left hand side of the equation, we have 4 exponent 2x plus y. Now if that happens, we can multiply the right hand side of the equation, that's the exponent, and we have 4 exponent minus 4. And then we have this side as 4 exponent 2x plus y. At this instance, we can see that the bases are the same, and so we equate the exponent. That becomes 2x plus y, which is equal to minus 4. Now in this instance, we can label this as equation 1. Now let's tackle the next equation. Now the next one we have 2 exponent x multiplied by 4 exponent y. Alright, let's clean it and write this well. So multiplied by 4 exponent y, which is equal to 8. Now we can express 4 and 8 for it to have a common base of 2 so that we continue with our solution, which means we have here as 2 exponent x multiplied by 4 is known to be 2 exponent 2, and then our existing exponent y comes, and 8 is known to be 2 exponent 3. Now in this instance, we can multiply the exponent, and we have 2 exponent x multiplied by 2 exponent 2y, which is equal to 2 exponent 3. Now with this, once the bases are the same at the left hand side of the equation, and then we can see that the bases are multiplying, then we write one of the bases and we add the exponent, which means 2 exponent x plus 2y is equal to 2 exponent 3. Now we can see that the bases are the same, so we create the exponent and we have x plus 2y, which is equal to 3. Now having known this, let's label this as equation 2. Now we can solve equation 1 and 2 simultaneously by the method of elimination. Others can use by the method of substitution. But in this video, we are going to use the method of elimination because it's the most easiest and simplest one. And so we clean the line. So by quoting equation 1 and 2, then it means from equation 1 we have 2x plus y is equal to minus 4. And equation 2 we have x plus 2y, which is equal to 3. Now, by the method of elimination, we want to eliminate one of the variables so that we can get the value of the other. Now, in this instance, we can multiply equation 1 by 1, and multiply equation 2 by negative 2, so that we can eliminate x. So if that happens, then our new equations now becomes 2x plus y, which is equal to minus 4. And when 2 multiplies, equation 2 becomes negative 2x. So negative 2x, negative 4. And then we have here as negative 6. Now having known this, then our simultaneous equation by elimination continues. Now we can add these two equations, and when we add 2x minus 2s is going to give us 0, and we know y minus 4y is going to give us negative 3y, which is equal to, now minus 4 minus 6 gives us minus 10. So it means dividing both sides by the coefficient of y, then means we are going to get our y value here to be equal to negative 3y minus 10 divided by negative 3 minus 3, and we have our y value now to be equal to 10 out of 3. Now we can get x by substituting the value of y, that is 10 out of 3, in equation 1 or 2, not the new equations we arrived at, but equation 1 or 2. And so we can decide to put into equation 1, and when we substitute, then we can boldly say that from equation 1, we know that 2x plus 4y plus y is equal to minus 4 is equation 1. So now if y is equal to 10 out of 3, then our x value now is going to be simplified as such, minus 4. So we have minus 4 here. Now in this instance, we can see that our LCM now is 3, so we multiply through by 3, and so 3 multiplies 2x, and we have here as plus 3 multiplied 10 out of 3, and minus 4 multiplied by 3, and we have here 6x. When this 3 cancels 3, 10 is left, so plus 10 is equal to minus 12. Now in this instance, you can group like terms and have 6x to be equal to minus 12 minus 10, which means our x value now becomes 6x is equal to minus 22. When divide here by 6, divide here by 6, then our x value now is equal to x, that is 6 cancels itself. 2 goes into 6, 3, and goes into 11, 22, 11, which means you have minus 11 out of 2. We can conclude our solutions as, therefore, x is equal to minus 11 out of 2, and y is equal to 10 out of 3. And this becomes the value of x and y. So this ends today's video. Thanks for watching. Kindly like, comment, subscribe and share. Kindly subscribe, comment, like and share. See you in our next video. This is BakoMaths, thinking beyond infinity.